Alright, so today we're doing centroids, and I worked out like a little example for y'all real quick. I mean, but here's the first couple steps of centroids. Well, centroids are typically, they are describing like the center of an object, and for a rectangle it is L over 2 and L over 2 over here. And for a triangle it is 1/3 from like the big part of the triangle, like the top part. 1/3 L. So typically in statics, you're gonna see eventually I-beams and T-beams. In I-beams, the centroid is typically right at the center because these two wedges are gonna be like, not wedges, flanges, are gonna be the same exact size. And we're gonna find a centroid for one of those. But first, I actually wrote down a quick example of a T-bar where it's quite simple. The formula just says summations of y times a and summation divided by summation of the area. So y bar is that object's centroid in the y direction, and x bar is that object's centroid in the x direction. So for this case, I did the y bar and I put the center of the object, which was 2.5 up. And remember, the x-axis for this case is your datum, and that datum is going to be like your reference point from like the zero mark. So if this is 2.5 up, then the y bar is 2.5 for part 1. But for object 2, the center of the object is 20 because you have to add the 15 of the middle of it and also the 5 because of the datum line right there below because it's on top of object 1. So yeah, so after that I made a little table so it's clear to see. So I could take the area first, then the y bar, then multiply the area and y bar together, so it's quick and easy, and I can just plug in the formula, plug and chug super fast. Alrighty guys, I'm back, better than ever, ready to do the first actual example for centroids. Alright, so for the first example of my centroids, I'm going to draw a random object, and we're gonna find I already found the y here, but I'm gonna find the x of it. So typically when you see your object, you're gonna be given a, what's it called, y-x axis, and you're gonna typically split these objects into different objects. So let's see. Okay, so I drew this weird shape. But in this weird shape, I identified that I see 3 objects that I could take centroids of. 1, this rectangle part, 2, this triangle part, and 3, this other rectangle part. But first, let me draw my dimensions. 10, 2, 4. And my x dimensions, 5, 8. Alright, so for this problem, we're looking for x bar. So to find x bar, we know the formula. X bar equals summations of x, y, squiggly, and area. So summation of area and x bar divided by area. So our first step for these type of problems is to make a table based on those shapes. So I made a table, it's a 3 by 3 table for the shapes. So I'm going to take the area, my first shape, x of my first shape, and ax of the first shape. So step 1 is to take the area. So I see that this shape is about 5 plus 8. Remember, these are your datums, and this is your datum. So the origin and the x and this datum lines. So they're like your reference points in this problem. So for 1, I have like a 8 by 2, 13, a 13 by 2 rectangle block. So the area of that is going to be 26. And we're looking for the x. So typically for rectangles, if you remember, 1/2 the length is the accentuate. So it's going to be 1 for this case, because it's 1 away from the reference point. But for this, it's just going to be, this is just going to be 26 because you just add them, you just multiply them together. So that's object 1. For object 2, we have 2/3 or 1/3 from the big part. So it's right here. So 1/3 of 10 is, I'm just going to do 10 over 3. Because, you know. So the area for this, it's a 5 by 10. So it's 50 divided by 2, because 1/2 base times height, 25. And the x bar for this is 10 over 3. And I'm gonna get my calculator and figure this one part out. But for 3, it's actually not 10 over 3, I actually messed up. That is the centroid of the object, yes, but you also have to include the reference point. So it's 10 over 3 plus 2. So it'll be 10 over 3 plus 2. And for 3, we're gonna do the same thing, find the x part of it. So the x part for this is 2, because it's a rectangle. So it'll be 2 plus 14. 2 plus 12, because 12, the reference point's 12 away from the y-axis because it's x, plus 2 because the centroid is plus 2 in the middle. So it would be this would be 14. And then we just take the area, which would be, let me see, the area would be, the area would be 5 by 4, so 20. And give me 1 second, I'm gonna get my calculator, I'll be right back. Dang, this scan sucks. Alright, we good? Alright, we better. Alright, so I put these in the calculator. 10 over 3 plus 2, 5.33 times 25, 133.33. And don't be alarmed by these big numbers. These numbers are gonna get big real quick since you're multiplying like something cubed, because it's like this is say meters and this is like meters squared, so this is gonna be like a meters cubed number, so it's gonna be big. But after that, if I put these all in the calculator, I'm going to have to add up my AX portion and add up my area portion to find my X bar of my object. Which will be 6. Your X bar will be 6.18. And does that make sense? Oh, sorry for that. Does that make sense? Let me see. 6 is around here-ish. So So I'm guessing Yale makes sense because this big part of the triangle is really, really like big. And it's gonna push it more skewed to the left. So since this object is skewed to the left, it's centroid in the x direction, we're guessing that is correct. So we found our x bar and we found our y bar for this video, and that's basically it.